Welcome to Honors Chemistry Test Hints for Chapter 2. We're going to do work on numbers 1 through 20 right now, and the next class will be doing 21 through 40. Number 1. Ready? No. Why is data organized, analyzed, and classified? What do we want to do with data? We want to learn something about it, so we do what to it? Well, yeah, we organize and all that stuff. Yeah. Go ahead. That's going to look beautiful when I post it on YouTube.
It's easy to find?
Yeah, but ultimately, I mean, we're not just taking data because we just want to organize stuff, right? We want to write conclusions, which implies that we want to find out what about the values, or the what?
More information.
More information. We want to find relationships. Okay, we're looking at how one phenomenon in nature relates to another one. Or is there a pattern with this data? Are we seeing something consistent or not? Alrighty. Number 2, how to identify a quantitative observation from a set of specific observations. So, the answer choices will be something like this. Which one is quantitative? Melts at 50 degrees Celsius. Turns yellow in the sunlight. Is wet. Weighs 57 grams. The first and the last one, why? They had something with numbers in them. Okay? Yes. That gives us some specific measured quantity. Alrighty? So how do we report qualitative results? Qualities or what? Well, I heard it over here. Descriptions. Descriptive information. Next to our definition of a hypothesis and definition of theory. Hypothesis is not a guess. Has nothing to do with guessing. No guessing. Okay, so what is it?
A testable statement.
A testable statement, or a testable question. Something we're wondering about, and can we develop an experiment that will allow us to test that phenomenon? Very good. Theory. This is a word that we have ongoing problems with in science, because it is not, we don't use theory the way we use the word theory in everyday life. You know, on TV or something, or in your conversation, say, oh, well, that's just so-and-so's theory. Theory to a scientist is a strong word. It is an important statement. So, what is a theory? Jasmine? Something concluded from an experiment. That could be part of it, but it goes a little bit beyond that.
Like the same things being shown, and it's like the pattern.
Okay. Now that, I'm glad you brought that up. Same thing being shown over and over and over again, and a pattern is a law. That's a law of nature, and people mess this up all the time. Just look at the regular chem tests. So, how then is a theory different than just this observation and pattern?
Is a theory like not proven?
It may not be completely proven. It may not be absolutely proven, although we're really, really good with some of them. The difference is the word explanation. Yes. Theory is an explanation. So we see, with a law, we see this pattern happening over and over and over again. The theory explains why that happens. Okay, so the laws are the what, theory is the why. Okay, and scientists are always asking that. Why did this happen? Alrighty, number 6, how to assess the validity of scientific concepts. What do? We experiment, absolutely. So we come up with this idea and we want to test it and test it and test it some more.
So you experiment many times?
Mhm. Okay, we don't just vote on it. Say, okay, who thinks this is right? That's not how it works. We test it over and over and
Are you
over.
looking off the test right now?
Huh?
You looking off?
Oh yeah, I always look off the test when I do test hints.
Oh, okay. I'm just making sure.
Sometimes I read you the exact question.
Yeah.
That's why coming to the after-school test review is a good idea. Alrighty, number 7. The characteristics of measurement standards. Okay? Somewhere over in France is a platinum iridium alloy kilogram mass. That is the standard of mass for the entire world. And everybody who has to measure mass has to compare to that object. Because it is the mass that the entire world agrees upon is going to be this equals 1 kilogram. Okay? So if I asked you to describe a standard, it's something we're sure about. It's something that all scientists or everyone agrees is going to be the value we're going to refer to, or the object we're going to refer to. When the people that make meter sticks are making meter sticks, they're comparing the length of those pieces of wood that they're using to make meter sticks to another platinum iridium bar that is kept in France under climate control conditions in a vault somewhere. It's like the Da Vinci Code. And then every country actually has their own Bureau of Weights and Measures, so every country has a replica of the ones in France. That's the International Bureau of Weights and Measures, and so that their trade can be consistent and measurement can be consistent. Okay, so we agree on it. It's a set size. It's a defined unit. There's no ambiguity about it. We're all sure of what this means. Number 8, the characteristics of units. How do we describe measurement units? Okay. If I say something is a meter long, how is it that we can all have a good understanding of, okay, what that length is?
Units.
But what about the unit?
It's consistent.
It's consistent. It's consistent. It is a defined size. It's attached to some sort of measurement. Right? So when we're reporting something out, we're not just writing down the units. We're writing down a measurement along with it, with a specific set of units. Okay? And would we use meters to measure the weight of something? No. What would we use to measure the weight of something? A balance, and what unit would that be? Grams. And what's the standard of mass? Kilogram. Very good. Okay. Number 9, the question says, all of the following are examples of units except what? And I think this one is going to be pretty obvious. So if I said